Is this thing on? Oh, you're already here. Hey, well, welcome. Today, we're going to talk about magnets. Well, welcome back. I was asked a question not too long ago by a bunch of first graders. They wanted to know about magnets. So I thought today we could talk about them for a little bit. Did you know magnets come in all shapes and sizes? Sometimes they look something like this. Call this a bar magnet. Now this one's kind of neat because they painted one side red and one side blue. That's because magnets have poles. That means they have different ends. We call these poles a North Pole and a South Pole. Have you ever heard of that before? Maybe if you've talked about the Earth, you've heard about the Earth's North Pole and the Earth's South Pole. Well, that's because Earth is like a big magnet. And the North Pole is on the top and the South Pole is on the bottom. Now, if I took this bar magnet and I was really strong and I bent it, I could create something called a horseshoe magnet. That's what this one is. Now, this one's only one color, but it still has a North Pole and a South Pole. One side is the North Pole, one side is the South Pole. Magnets have poles, a North Pole and a South Pole. And the two North Poles will push each other away, or repel each other. And the two South Poles of different magnets will push each other away. They'll repel each other. But a North Pole and a South Pole will attract. Let's take a look at this. Now we're going to work with some circular magnets. There's a North Pole and a South Pole to these magnets too. And I can stick them together. And I know that the North Pole of one is sticking to the South Pole of the next. What's really neat is if I flip one of these magnets around, it's repelling. Now, I can feel this, but how can I show you? Now, I've stacked these magnets so that the poles that are alike are trying to touch each other, but they're repelling each other. And if I take this magnet, do you see how the other ones are moving too? I can actually lift this magnet up off the dowel without even touching it. There it went. These magnets are interacting with each other. I can also show you this with some cars. Now I have a magnet right here. It has a North Pole and a South Pole. And I'm going to put it in the car. And I have another magnet right here. What's going to happen when I push the cars next to each other? Well, it depends how the magnets are lined up. Oh, they stuck. That means that one had the North Pole facing out and one had the South Pole facing out. And so they attracted each other. But what would happen if I reversed one of the magnets? Take this magnet, I'm going to flip it around. So what do you think will happen now? Well, think about it. Maybe you could talk to the person next to you. You could pause this video. When you're ready, just hit play. Okay, here we go. Let's see what happens. Oh, that car is backing up. Let me push the other side. The cars aren't actually touching, but the magnetic fields are pushing each other away. Did you know magnets can be found naturally on the Earth? There are some rocks that are magnetic. This is a rock that's magnetic. It's called magnetite. Looks like a rock to me, but if I take another magnet, I can stick it to the rock. So the question that I was asked is really about what makes a magnet a magnet. Well, for something to be magnetic, it needs to have a magnetic field around it. Now, the tricky part is we can't see a magnetic field, but I can show you it in a different way. To see magnetic fields, I'm going to use a magnet. I'm also going to use this special device. This is a plastic container that's sealed, except there's a hole that goes straight through, all the way to the other side. And trapped inside the container, there are iron filings. These are little pieces of metal. If I take my magnet and I put it in the container, I give it a little shake, the iron filings line up on the magnetic field lines. If I move the magnet, you can see them moving. And if I take the magnet out, it just looks like metal dust. So now we know magnets have magnetic fields that surround them. Those magnetic fields interact with other magnetic fields, and that's what makes magnets stick. Now, the magnets themselves are made out of materials that can create these magnetic fields. Typically, this is iron or cobalt or nickel, and there are certainly other things too, but those are the popular ones. So my magnetite rock, that has a lot of iron in it. Now, some magnets are permanent, and some are only temporary. For the last thing in this video, we're going to create a temporary magnet. And you might want to try this at home. Well, if your parents want to help. So for our last experiment, you're going to need a really strong magnet. You're also going to need a sewing needle, a shallow bowl, a pair of scissors, and some waxed paper. The first thing you want to do is you want to make sure that this needle is magnetized. Now, what's really nice is if you use a strong magnet and rub it along the needle, you will make it magnetic. I think that's pretty good. And then I'm going to fill my bowl with some water. Now I'm going to take my wax paper and cut a small square. And I'm going to take my needle and I'm going to thread it through the waxed paper. Just like that. Now I'm going to take my needle and my paper and I'm going to float it on the water. Watch what happens. Did you see how the needle turned? See how it's facing in a line, just like this? Let's try it again. Make sure it does the same thing. I'm going to take my needle. I'm going to put it in like this. And it turns in the same direction. So what magnetic field could be influencing my magnetic needle? Well, it's the magnetic field of the Earth. And my needle is pointing towards the north. If you ever need to make a compass, this is an excellent way to start. So what do we know about magnets? Well, I know that they're typically made of iron or cobalt or nickel. I know that they can create this invisible field around them called a magnetic field. And those magnetic fields can influence other magnets. I know that magnets have poles, a north pole and a south pole. And that like poles repel or push each other away, and opposite poles attract. I also know that I can make a compass, and hopefully you can give that a try. So before we go, how can you tell if something's magnetic? Well, you find a magnet and you see if it sticks. I bet you have some magnets at home. Maybe you're on your refrigerator. Well, take one down and walk around your house. Is your chair magnetic? Is some of your toys magnetic? It's pretty easy to find out. I hope you go exploring. I'll see you later. Anybody know how to shut this thing off?